Now that you know how to create a box and whisker plot, it's important to be able to read and understand information shown in a box and whisker plot. And so we're going to start with example number 3 on page 20. And it says, which statement is true about the double box and whisker plot? We call it a double box and whisker plot because it's two different box plots on one number line. And so if we look at the data here, all right, the top box and whisker plot is referencing your class, and these are their test scores. And then underneath, the bottom box and whisker plot shows your friend's class and their test scores. And we want to know which one of these statements is true about this double box and whisker plot. Okay, so letter A says half of the test scores in your class are between 85 and 100. Okay, so we have to find out where those values are. Okay, so we're looking at your class, so we're looking at the top box plot, and it says half the test scores are between 85 and 100. Okay, and it's important to remember that each part of the box plot shows 25% of data. So from the minimum up to Q1, this is 25%. Okay, from Q1 to the median, this is 25%. From Q2 to Q3 is 25%. And from Q3 to the maximum is the final 25%. So this says that half the scores are between 85 and 100. So let's figure out what these values are for your class. Okay, in your class, 85 is your Q1 value, and 100 is your maximum value. Between Q1 and the maximum value is that half of the test scores. Well, from Q1 to the maximum is 25, 50, 75% of the scores are from 85 to 100. That is not half of the test scores, it's 75%. So A is out. Okay. B says that 25% of the test scores in your friend's class are 80 or above. So we're going to do the same thing that we did now for your friend's class. Remember, this is 25% here. Here's 25% of the data. Here's another 25% of the data. And here's the last 25% of the data. Okay, 25% of the test scores in your friend's class are 80 or above. So we find where 80 is on your friend's class. Here's 80. And 80 right here is the median score. The median score, okay? 80 or above, well, that's 25, 50% of the scores, not 25%. So B is out. Letter C says that the medians are the same for both class. Well, that's really easy to look for, okay? We just said that in your friend's class, the median score right here is an 80, but in your class, the median score right here is a 90, so they're not the same. That's false. So it has to be choice D, and let's read what choice D says. The test scores in your friend's class are more spread out than the test scores in your class. When they're talking about how spread out the scores are, they're talking about the range, okay? So we can actually prove that by looking at the range for each class. If we look at your class, okay, for the range, remember that you're calculating the highest minus the lowest. The highest score was a 100. The lowest score was down here, maybe at about, I would say 67. That looks like it could be. Okay, between 65 and 70, a little closer to the 65. So I'll go with 67 on that. So if you do the range of scores in your class, 100 minus 67, that's going to equal 33. If you do the same thing for your friend's class, again, we're calculating the range when we're talking about how spread out the scores are. The high score was a 100. The low score down here was a 60. 100 minus 60 is 40. So your friend's class has a bigger range than your class, which means that your friend's class, the scores are more spread out than in your class. So D is a true statement. In example 4, it says that from the graph, it is clear that the age group of men counselors is more spread out than the age of women counselors. And again, they're talking about being more spread out. So they're talking about the ranges in their ages. And so we can find the range for the men counselors and the women counselors very easily. Okay, so if we find the range for the men counselors, the highest age is right here at 32. minus the lowest age right here, which is apparently about 21. Okay, 32 minus 21 is equal to 11. All right, and now if we do the same thing for the women counselors, okay, for the women counselors, their range, well, the highest age right here is at 26, and the lowest age right here is at 19. 26 minus 19 is equal to 7. So again, it says it's clear that the age group of men counselors is more spread out than for the women counselors. Well, look at the ranges. The men counselors have a bigger range, which means that their ages are more spread out. So this is a true statement. Number 5 says that more students in Mrs. Rose's class scored between 66.5% and 84% than between 84% and 91%, because the box is longer between 66.5% and 84% than between 84% and 91%. Is this a true statement or is this a false statement? Okay, so we have a lot of information to try to digest there, okay? Notice it's a double box and whisker plot, but they're only referencing the scores in Mrs. Rose's class. So I don't care about the top box plot because that's Mr. Josh's class. So we're only going to look at this bottom box plot here. Okay, it says that more students scored between 66.5 and 84. Let's figure out what those numbers are. Okay, for Mrs. Rose's class, 66.5. Okay, well, that appears to be between 60 and 70 right here. This line right here, okay, this appears to be the 66.5. So I'll put it right down here. That's 66.5. And this is your Q1 value. Okay. 84, well, between 80 and 90, it appears to be this right here. So again, I'll drop this down, 84. This is your median value. This is Q2. Okay. Well, between Q1 and Q2 is 25% of the data, remember. Okay, all of 25% of the data is between Q1 and Q2. Okay, so more students scored between 66.5 and 84 than between 84 and 91. Between 84 and 91, which is right here, here's 91. Well, this is the Q3 value. Between 84 and 91, between Q2 and Q3, is also 25% of the data. Okay, so did more students score between 66.5 and 84 than between 84 and 91? Well, no, that's a false statement. Okay, this is a false statement. 25% of the students scored between 66.5 and 84, and 25% of the students scored between 84 and 91. Just because this range is bigger doesn't mean that there's more scores in there. Okay, the same amount of students scored in this range that scored in this range. This is a smaller range, but it still contains the same amount of students. So 25% of the data is between Q1 and Q2. 25% of the data is between Q2 and Q3. So this is a false statement. Just because this range is bigger doesn't mean that more students were in that range. Number 6 says to compare the surfboard prices of Shop A and Shop B, they want us to make 3 conclusions based off of the double box and whisker plot. Okay, so these double box and whisker plots show the surfboard prices in dollars at Shop A and at Shop B. And looking at these box plots, what are 3 conclusions that we could make? Okay, and the first thing that jumps out to me is that for Shop A, okay, most of the data in Shop A is to the right of the data that we see here in Shop B, which would lead me to conclude that surfboards tend to be a little more expensive at Shop A than at Shop B. And so I'm going to write that down as my first conclusion. All right, surfboards tend to be more expensive at Shop A than at Shop B. Okay, And my explanation got chopped off there. There we go. We can see it now. Surfboards tend to be more expensive at shop A than at shop B. Now, that's not always the case. We can find a surfboard at shop B. Their maximum surfboard right here is more expensive than the cheapest one at shop A. But just in general, okay, this box and whisker plot seems to be a little further to the right than this box and whisker plot at shop B. So surfboards tend to be more expensive at shop A than at shop B. Okay, well, what's something else that we might be able to conclude? Well, we talked about spreads in a couple of questions before. Which shop has the bigger spread? Well, again, we're talking about the ranges there. And again, I would say shop A, if you look at their highest and lowest, they tend to be more spread out than the highest and lowest surfboards at shop B. So maybe I'll say that the prices at shop A are more spread out. Than at shop B. Okay, the prices at shop A are more spread out than at shop B. What's another conclusion that we could make? Okay, well, maybe we want to know which surfboard has the most expensive, which shop has the most expensive surfboard. So to do that, I would look at the maximums, and I can see that shop A's maximum is higher than shop B's maximum. So maybe I'll say shop A has the most expensive surfboard. Okay, I can even make one more conclusion. I'll add a fourth one in here. Maybe I want to know where the cheapest surfboard is going to be. Well, again, look at the minimum values here. I can see shop B's minimum is lower than shop A, so I could say that shop B has the cheapest surfboard. The cheapest surfboard. So again, you're just looking at this and you're making some general conclusions. Generally, the surfboards tend to be more expensive at shop A than at shop B. The prices at shop A are more spread out. Shop A has the most expensive surfboard, while shop B has the cheapest surfboard.